Okay, this is question 12 onwards from the November 2018 Maths Higher Paper 1. Okay, questions 1 to 11 are in 2 other videos. Okay, question 12. Catherine's measuring the force between a pair of magnets physics lab. It is known that the force F is inversely proportional to the square of the distance. So this is probably about as bad as it's ever going to get on a proportion question. Okay, so you've got to have your proportion symbol, the fishy. It's inverse, so 1 over, and it's the square of the distance d, so d squared. Okay, so that's your opening line, and then immediately that becomes F equals K over d squared. Okay, the fish always sort of swaps to an equals K to allow us to put some numbers in and work out what K is. The numbers we've got is that the force is 4 when the distance is 10. So F is 4 when d is 10. So K over, now don't forget the squared, 10 squared. 10 squared is 100. Bring it up and multiply. 4 times 100 is 400. So K is 400, or 400 equals K. You're not done there. You've always got to go and put that back in. So go to your second line, put K back in. So F equals 400 over d squared. If the question was split A and B, that would get you 3 marks for part A. So you must make sure that you go back out. Right, now we've got to work out the distance when the force is 100. So if F equals 100, 100 equals 400 over d squared. D is what we want to work out. D is on the bottom of a fraction, so we're going to have to do some rearranging. Swap those two around, so d squared comes up, 100 goes down. So d squared is 400 divided by 100. D squared is 4, and the square root of that is 2. Now, if it wasn't a real life question, the other square root, so if we say that d is the square root of 4, that's not the only solution when you square root. It could also be minus 2. So if there was no real life context, it could be either positive 2 or negative 2. But because this is real life, you can't have a negative distance between magnets. So you wouldn't have to put this negative solution in this time. Okay, so just d is 2. And there's nice easy 5 marks, reasonably straightforward, as long as you get the opening sort of expression correct. Right, question 13, making C the subject. We've already changed the subject earlier on in the paper. The only difference is that this time the subject C appears twice. And at the minute it's in the numerator and the denominator of a fraction. So we can't have that. Remember, your subject can't be negative. It also can't be tied up in a fraction, especially not the denominator. So our first job is going to be to bring that denominator up and over, get rid of the fractions. So 6c minus 3d is equal to g times, and I'll put it in brackets because there's 2 terms, c plus 2. And then expand those brackets out. So 6c minus 3d is equal to gc plus 2g. Okay, we're making C the subject, so I need all my terms that have got C in on one side of the equation and all my terms that don't have C on the other side. I mean, you've got a bit of a choice here. You can go sort of either direction, but I'm going to take that GC over to the left, and I'll take minus 3D over to the right. And that will give me, so 6C, which was already there, take away GC, which is the one that came over, is equal to 2G, which was already there, plus 3D. This is now the step which makes this an A grade question. We've got C appearing twice. We only need C to appear once because C's got to be on its own as the subject. And the way to do that is to factorise C outside of some brackets. And then left inside your brackets is 6 minus G. And then on the other side is 2G plus 3D. And then to get C on its own, that bracket, the 6 minus G, we're going to have to divide by that because it's multiplying at the minute. So 2G on the top plus 3D, all divided by 6 minus g. If you did it the other way round, you'd have something like minus 2g minus 3d all over g minus 6, or minus 6 plus g. Basically, all your signs swap around if you move things the other way, left to right. Question 14. Hopefully you'd spot that that's arcs and sectors. Okay. Normally, you'd see circle-related things on paper 2 because you'd need a calculator to work with pi. But if it's on paper 1, probably just leave your answer in terms of pi. Okay, so let's have a look. We've got two sort of sectors. They've both got a radius of 30, and they're both 20 degrees. And I know they're equal because I can use opposite angle rule for low down in school to say that opposite angles are equal. Rather than treating it as 2, I think what I'll probably do is say that that's just one 40-degree sector. So the formula for area of a sector, 40 over 360 times pi r squared, so times pi times 30 squared. We can make that a bit nicer. 40 over 360 simplifies to 1 over 9. Okay, so that's 1 over 9. And very often, if it comes up on the non-calculated paper, they do simplify nicely. Times pi, 30 squared is 900. So we've got 1/9 of 900. 1/9 of 900 is 100. So that comes out as 100 pi. Okay, just leave it like that. Then it says we've got a second circle whose area is the same as the shaded section above. So this is now a different circle. The formula for a circle is pi r squared, but it's got the same area, which is 100 pi. The pi's just cancel out, which is sort of the benefit of leaving it in terms of pi. We're left with r squared equals 100. The square root of 100, okay, it could be 10 or minus 10, a little bit like on the proportion question. But again, you can't have a minus radius, a negative radius, so you can forget about that, and the radius of the second circle must be 10 centimetres. Okay. Question 15, this is a very straightforward question, and it's only 2 marks. This is the x10, x100, x1, so only the 7 is recurring, so 0.377777. Let's do a couple of those. Remember now, we keep going until we've got matching rows after the decimal point. So 10x would be 3.7777, they don't match. 100x is 37.7777. I'll get a highlighter because we've got 2 matching rows. All of those 7s there match up with those 7s there. So we're ready to sort of subtract our 2 rows. So we'll do that one, take away that one take away that one, which leaves us with 90x on the left hand side. Now don't forget about the 3, it's 37, take away 3. Even without the 7s, you still got to do the little bit taken away, which is 34. X equals 34 over 90. Okay, a lot of people forget about the number there and would just leave it as 37 over 90, but you have got to take away the 3, so be careful. Make sure your fraction's the right way around at the end. Okay, expanding brackets with surds in, so it's squared, that means it's the same bracket twice. And then use FOIL. And it helps if you know your shortcut rules for surds. So root 8 times root 8 when they match, so root 8 times root 8 is just plain old 8, both positive. Root 8 times root 2, so root 8 times root 2 is root 16, and root 16 is 4. We've got a positive times a negative, so minus 4. Then we've got same thing again, so root 2 times root 8 is root 16, root 16 is 4, negative, positive, so that's exactly the same. And then last of all, we've got root 2 times root 2. Again, you can use your shortcut. That's just going to be 2. we've got a negative times in a negative, that makes a positive, so plus 2. 8 to take away 4 is 4, take away another 4 is 0, add 2 is 2, okay? And it doesn't say to write it down, but that is rational. Right, down the bottom there. We've got to simplify this best we can and end up in the form a root b. Okay? If we follow the rules for times and then dividing surds first of all then, so 6 times 20 is 120, so 120 on the top, over root 3. The rules of dividing say that as long as they're both under roots, you can just divide by each other, so 120 divided by 3 is root 40. And then you've just got to find a square number that goes into 40. The biggest square number you can, that's a factor of 40, to simplify that down. It's not particularly great, okay. The biggest square number that goes into 40 is 4. So root 4, root 10. The root 4 becomes 2. The root 10 stays like it is. So your final answer is 2 root 10. Then we've got, we did a bit of indices work earlier on in the paper, so it's slightly more difficult. You've got 3 things to do here. We've got a denominator of 2. The denominator tells you what type of root to do, and I'd always do the root first to keep the numbers small. 2 is square root. So we've got to square root 16, which is 4. The 3 on the top is telling us to cube that. So we've got to do 4 cubed. 4 cubed is 64. 4 times 4 times 4. The minus, when it's in a power, is 1 over. So it's 1 over 64, which is not particularly nice, so it's lucky they haven't asked us to convert it to a decimal, because we'd be struggling a little bit. Right, number 16. Asking us to simplify, so what we're aiming to do here is get 2 brackets on the top, 1 on the bottom, and there's something there will cancel out. Okay. On the top, this is the ABC factorizing, the longer version. So you're looking for a pair of numbers that multiplies to make minus 8, adds to make minus 7. The pair is minus 8 and 1. So I'll just work separately. So 4x squared minus 8x plus 1x minus 2. Split it in half to factorize. You can take 4x outside, which leaves x minus 2 on the inside. We've got to take something out, so that'll be a 1. The signs are okay, so it's plus 1. X minus 2, matching brackets is always a good sign. And then put it all back together again, so that's 4x plus 1, x minus 2. So that's our numerator. So if I put that over here, so 4x plus 1 over bracket x minus 2. The bottom of the fraction is nice and easy to factorize, actually. It's a single bracket. You've just got to look at what they both can be divided by. So 4x minus 8, they both divide by 4. So 4 comes outside, leaving us with x minus 2 inside, which is a very good sign because I've already got an x minus 2 on the top. So I can strike through, cancel those out, and my final answer would be 4x plus 1 all divided by 4. Okay. Just 2 bits of factorising, but as long as you know you're aiming to cancel out one bracket from the top with one bracket on the bottom, there are clues, so you'll know if you've gone wrong because your brackets don't match at least. And we'll stop there and I'll do the last 2 questions in a separate video because I'm just running out of time on this one.